This video absolutely killed me, but the end result is absolutely awesome. I can't wait to show you guys how to do it. Today's video is going to be all about how to create an object pool and how to incorporate it into a projectile system. We'll start by creating the object pool itself, and then implementing a couple of macros and functions to calculate the trajectory of the bullet and then spawn it in the right place. This video will be a little bit longer, but I hope you guys stay all the way to the end because there's lots of good stuff and lots of good information in this video. If you guys are new, my name's Taken Grace, and I make Unreal Engine tutorials and videos just like this. So if you want to become a better game dev with me, join the channel, join the community, and let's become better game devs together. All right, let's jump in and get started. All right, let's get started here, guys. Super excited to get this going here. So let's get started. So we're in our data folder here. Let's make a new folder and we'll call it object pool. So the way this works, we're going to create a blueprint actor. We'll call this BP underscore object pool class. So essentially, this is going to be the grandfather class for all of your object pools in the game. So this is going to run the logic for each individual item, and then we're going to make a component after this that is going to be basically holding and managing all of the actual spawned actors. Okay, and then by doing it this way, we can even create the class now. We can create a child blueprint class, and we'll call it BP underscore mullet manager. Could you imagine? You just had an object pool full of mullets? That'd be awful. Anyways, mullets are making a comeback along with mustaches, apparently. I don't know why. I thought that fashion statement was over. But anyways, bullet manager. Okay, so this is a subclass of this. This bullet manager is going to manage all of our bullets in our game. Okay, so that's what that's going to be for. You can make another child class, which we're going to do in a future video where we make our bullet holes. We're going to make decals. So we're going to make another object pool with just decals, bullet hole decals. And then you can make another one for just footprints, another one with just enemies. So you can, like, this is a hugely scalable operation that we're doing here. So, okay, let's open up object pool class. All right, so the first thing in here that we need to do, we need to add a box collision. And we need to do that because we need to make this the root. So we'll just call it box collision. Okay, we need to make this the root of the scene. And we have to do that here because in the children classes, you cannot make a new root. And if you pay attention in Unreal Engine 5, I'm sure if you open up a character blueprint, like see we have our first person mesh, first person camera, we also have this mesh here randomly. You cannot delete this. If I hit delete, it won't work. And if I right click, I cannot delete. And that's because this is inherited. This first person character is inherited from the character class. And the character class has this mesh in it. So we can't delete stuff that it's inheriting. Okay? So we have our box collision. One other kind of debuggy thing we're going to do, which is kind of a nice practice. So this object pool class needs to be in the world in order for it to work. So you basically have like a collision box, and if you have a bunch of collision boxes from all of your different object pool classes, you're not going to know what any one of them are. So to get around that, you can add a text render, and we're going to just rotate it 180 degrees because then it'll be facing the right way. And then we're going to make a variable, which is just debug text, and that'll be just a text. And come up here to the construction script, and we're going to grab our text render, and we're going to set text, and we're going to plug in our debug text. Okay, our debug text should be instance editable because we're going to edit this for every instance of every blueprint. Okay, let's hit compile. Okay, now back in our, we can actually edit this now. All of our children are going to have this by default, and we'll just have to change it, but we'll call this the object pool class. Okay, and now in our viewport, you can see that it says object pool class. And if we hit compile and you just move this over here, and now we zoom out here and we drag, where were you? Data, object pool. If we drag the object pool class into the world, you see that it says that. Okay. Let's just drag in the bullet manager as well. Let's go into the bullet manager and let's just change that text. So we see that it's something different up here in class defaults. Bullet manager. Okay, and now when we look, it says different. Okay, so now you can keep track of what little boxes are what. Super handy. So, okay, in our object pool class, let's make some variables. First one is going to be a Boolean called in use. Next, we need to make a variable called lifetime. And there's a reason we're making this and not relying on the lifetime stat that's in class defaults, I believe. Oh, initial lifespan. Yeah, we're not gonna deal with that because we want this lifetime to be unique to each individual object pool class. All right, let's go to our event graph and let's make some stuff. So we're gonna get rid of literally all this. We don't need it. We're gonna make a custom event, and we're gonna call it set in use. We're gonna be referencing this a bunch in the tutorial here. So we're gonna make a variable called in use. Okay, and then we're gonna set our Boolean based on this value. Okay, so this is going to control if our object is in the pool or if it's being used. If it's being used, we're going to pull it out of the pool, we're going to use it, we're going to do a bunch of stuff with it, and then when we're done with it, we're going to set not in use to false, and it's going to put it back in the pool. Okay, that's how that's going to work. First thing we'll do is we will set actor. Well, we need actor tick enabled. I just saw that one first. Set actor hidden in game. And what's the other one we need? Set actor collision enabled. Okay, so we need to get those three nodes: set actor hidden in game, set actor enable collision, and set actor tick enabled. Okay, so let's plug all these in. And then we're gonna plug in use into this one. We're gonna do in use, but not. Get a not B. I say not B because that's what I have to type to actually get it. If I just type not, yeah, it's up here, but I call it the not B. But anyways, so this has to be not in use because if it's true, if new hidden is true, that means it's hidden. If we're using it, we want it to be not hidden, if that makes sense. So, okay, and then lastly, obviously, we in a set tech actor and yes. We're gonna set actor tick in use. Okay. All right, that is basically the important stuff. Just to make sure that's optimized when we're not using it. Obviously, we don't want it to be ticking or doing anything, you know, that's going to detriment our performance. Okay, so now that we've done all these, we're going to grab in use again, and we're going to get a branch. And we are going to plug this in. And if it's in use, then we want to start a timer. So we'll drag out a true, and we'll set timer by event. And this is where we're going to plug in lifetime into time here. And we're going to make an event, or another custom event here, and we're going to call it reset. Okay? If we're resetting, we are going to call the set in use event. Set in use. I had it. There it is. Set in use to false. And then we are going to promote this return value to a variable. And we'll just call it handle. Okay? And we are going to then clear and invalidate timer by handle. Okay? Last thing we need to do, out of false, we need to get that handle again. And we need to clear and invalidate timer by handle again here. All right, so what's happening here? So we have this set timer by event. So if we are using the item, it's going to start this timer. When this lifetime timer finishes, it's going to fire this reset event. It's going to set in use to false. Then it's going to set and or it's going to clear and invalidate this timer by handle. So it's going to clear this event, and it's basically going to turn all of this stuff off. Okay, we have this because when our bullets hit something, we're going to call this set in use event, basically making it false, and then we'll clear and invalidate the timer again. Okay, and by doing that, if our bullet happens to not hit something for its lifetime, it's going to basically just say, hey, it didn't hit anything, let's put this back in the pool, because obviously it's way the hell out there. So like our sniper rifle bullet, for example, will be like 3 seconds. If your sniper rifle bullet's flying for 3 seconds at 80,000 millimeters per second or whatever the hell we put it in here as, then obviously you're not going to hit anything, or it doesn't matter. There's no way you're hitting shots like that. So, so yeah, that's going to basically clear and invalidate this and reset it, okay? That's what it's for. All right, this is done. Let's hit compile. We're going to leave all of our stuff open today because we're probably going to reference it quite a bit. We are going to now go to back to our object pool. I don't have a components folder, and that's fine. I just want to keep all my object pool stuff together. I'm going to make a new blueprint class, which is an actor component, and we're going to call this BPC underscore object pool manager. Sure, we'll call it that. Okay, object pool manager. We're going to open that component up. So remember, this is going to be managing all of the actual object pools. So we're going to spawn all of our bullets in here. We're going to put all of our bullets into a pool, and then we're going to pull and put stuff back in the pool from this particular component. The benefit of doing it this way is now you can reuse this component in any of these sub things: bullet manager, footprint manager, enemy manager, whatever. So you can reuse all of these, and then we're going to set the object that we want to pool in each one. So super scalable. Hopefully this helps you guys in future projects as well. Okay, so let's start with some variables. So let's start with obviously the thing we want to pool. So it'll be the pool object class. And that's going to be of type BP underscore object pool class reference. Okay, so this will be instance editable. And yeah, this is where we're going to set, if we compile it, we don't have anything yet, but this is where we can set any of the objects that we make a parent of this class to be spawned in, okay? The next one is going to be the pool size, which will be the, where is it? An integer, so we're going to tell it how big the pool size is going to be as well. So we're going to obviously make that instance editable as well. And next, the variable we're going to make is the actual pool. So we'll call it the pool, and we're going to make this a object pool class as well, and it's going to be an object reference. Let's come up here to the little pill. We're going to make it an array. So we're going to add multiple things to here, and it's going to be great. All right. First thing we need to do is on event begin play, we need to confirm that this pool object is valid. So we're not setting it, sorry, we're getting it. And then converting it to a validate get. This is here as a failsafe. Realistically, this should be valid pretty much every single time, but I didn't have this at one point in my prep project, and I got a bunch of errors, so I'm going to leave it in there. So next thing we need to do is we are going to delete, we're going to delete event tick. We're going to make a custom event called initial, goddamn tooltip, initial pool size, or pool, yeah, initial pool, how about that? Okay, and then let's call that event out of the is valid, initial pool, there we go. Okay. So that's created. So let's create the pool. So let's grab our pool size and get that. We're going to drag out of the execution pane. We're going to get a for loop. Down here, for loop. We're going to plug pool size in. Let's make the pool size by default 1, just so there's more than one item by default. Obviously, that'll be way higher for all of them. Okay, so we've made the for loop, and out of each single one, we are going to spawn actor from class. And that spawned actor will be our object pool. Okay, there needs to be a transform in here, or you're going to get an error. So just pull out of here, make transform, and just leave it at 0, 0. That'll put it at the world origin, because we don't need it anywhere in particular, so we'll just hold everything at the world origin. Okay, so now when we hit compile, that error should go away. Okay, after we spawn the actor, let's grab our pool. Let's add, and let's drag this in and plug this in. So we're going to add the spawned actor from the pool size to our pool, okay? After that, we are going to drag out a return value, and we're going to set in use to false, because we don't want this, we don't want any of these actually doing anything. We just want to spawn them and have them essentially ready for us to use, okay? Okay, so before we go into some more stuff here, we need to create another function, but let's create an event first. So let's do a custom event, and we're going to call it add one more item, or one more object. Okay, so out of here, let's get a sequence. Let's drag from then 0 and drag into spawned actor. And then let's create another function, and we're going to call this function spawn from pool. Let's come back to the event graph and just plug this in. We'll need to come back and plug in transform later, but so what this is doing, so if your pool size is ever empty and we're trying to spawn an actor from the pool and there's nothing there, you're going to get some errors. You don't want that. You want to spawn another actor, because you obviously need it if your pool size is empty. So add this this event. This event probably will never get fired, if ever, but if it does, it's here. Basically, we'll fire this event saying, hey, we're out of objects. Spawn another one, add it to the pool, and then we're going to spawn that actor we just made from the pool, okay? So that's just a nice little workaround, but now we're going to go into spawn from pool, and we're going to do this one now. So we need to make another function, unfortunately, before we start this one, so let's make that now. So we'll call it find available object. Okay, and let's get started with here. So first we will grab our pool, and we're going to get a for each. All right, let's plug that in. All right, so we will need to get an isValid here. So, okay, I was talking with a few people I was talking with a guy in my Discord, and he uses C++, and he says that you can never have a null inside an array. However, in my prep project last week, I did have a null. I had 19 of them, to be exact. What was happening is I spawned 19 bullets into my pool, and then my pool, I don't know, for some reason they had the what's it called, the projectile movement enabled, so they like fell all the way down into the kill Z volume, and then the world destroyed them. So I had literally had 19 variables in this array with no data in it, which made no sense, and it really confused that guy I was telling on in Discord. But anyway, so I had to add this node in order to get rid of that, essentially. Okay, but what we really need to know about this after it is valid is it in use? Is that right? Yeah, in use, sorry, get in use. Okay, is it in use? We're gonna get a branch, and we don't want it to be in use. If it's not in use, that's great. We're gonna get a return node, and we're gonna exit this function and get the hell out of here. We're gonna plug array element into the return node so that we get a essentially a available actor. Okay, there it is. Okay, so if it's in use, we don't care, we don't want it. If it is not in use, we care, we want it. If we've gone through our entire pool and we have not found an object that is available, that means that we're out of objects, and that means out of completed, we need to add one more object, and then we need to hit a return node, and then the available actor is going to be empty. Okay, so just remember that, because we're going to make another isValid node outside of this. Yeah, that's it. So let's hit compile. Let's go back to the spawn from pool, and let's find available object. Okay, let's click on this input. We need to have another transform, because we need to tell this new item that we're about to spawn, or move, sorry, from our pool where to go. So we gotta transform. And we'll make it a transform. Okay. All right. So out of the available actor, this is where we're gonna get that is valid, because if we've come out of completed, that means that we don't have an actor that's available. So it's gonna exit this, and then it's gonna come out of is not valid, and it's not gonna do anything. So it's gonna be great. All right. After that, we'll grab the available actor, and we will set actor. Oh, transform. Okay, let's plug it in from isValid. Let's plug in our transform. We can just grab this and go transform. So this is new per 5.5. Somebody asked me this in my Discord. So you'll see here that we have a little F with an arrow in here. And then you'll see another one here with a V, and then one that's just normal. This just is referencing the type of variable that it is. So this is a function input, and if it has a V, that is a local variable, and if it's this just a regular one without this, it's just a regular old variable. They added that in, I think, to just eliminate some confusion, because you could get, you know, transform, and if you had a variable and a function input and a regular variable, it would all show up and you wouldn't know which one to choose. So I think they just did that just to make it a bit easier. Okay, next let's make sure teleport is checked, because if your bullet is 24,000 millimeters away, you're going to want to teleport it without it interfering with anything. Okay, and finally we are going to get our available actor once again, and we are going to set in use. Okay, and we're going to set that as true. So obviously I have access to this because this available actor is an object pool class reference. So we made that in our parent, so we have access to it here. After that, let's hit a return node. That is all. Okay, so that's the spawn from pool. Let's hit compile. Let's go back to the event graph and plug in this transform. So don't worry about the fact that we're setting these as 0. We're going to call this spawn from pool inside our weapon class, and our weapon class is going to have the proper transforms that we need to move our bullet to the right spot. So since this is an input, we'll just input that data when we call this event from the weapon class. Okay, so that's that. One last thing we need to do in regards to the setup of the object pool, and that's in our bullet manager. We need to add this component now. So let's add the object pool manager, and we'll call this one bullets, and we'll duplicate that, and we'll call this one rockets. Okay, so we'll need to come back here later because we can't set our object pool call. I called it that? Oh, object pool actor, we'll call it. Okay, and anyways, but yeah, so we'll come back here and we'll have to set this later because we don't have access. We haven't made the projectiles yet, so, we can set the pool size if we want. So bullets, 18 probably, because remember in this project, I don't know if your guys' games are different if you're only doing a projectile system or not, but for the pool size, only the sniper rifle has access to the bullets. So there's 4 per clip, and even if I have 3 enemies and me that all have sniper rifles, and we all shoot and empty our clips at the same time, we're still only using 16 bullets. We'll have 2 in reserve, so I think 18 is plenty. Rockets, I'm gonna do 3. And remember, 0 is included in this, so this is technically 4. Again, rocket launcher has 1 clip, rocket per magazine, so we're not going to blow through that in any way, shape, or form, but it's there in case we need it. Okay, that's the end of the object pool stuff, so hopefully you guys have learned something. If you guys are jumping off the video now if you don't care about projectiles, but if you do care about projectiles, we're going to get started on that now. If you guys have liked the video, definitely throw a like over there. Helps me out. Helps you out. Okay, so let's go to the weapons folder, and let's make a new folder called projectiles. Okay, so let's make a new blueprint class, and we're going to go to all classes, and we're going to search for BP object pool class, because we want that to be our parent class. Okay, and we'll call this BP projectile base. Okay, and let's just make the children right now. So let's right-click and go create children class, BP underscore rocket projectile. And one more, BP underscore bullet projectile. Now we can go to our bullet manager and we can set those. Rockets, the rocket projectile, and bullets, bullet projectile. Okay, that's all done now. Great. So let's open our bullet base, or projectile base. Okay, in this we have the text. If we wanted to set that, we can. Class defaults up here. This is the projectile base, except this won't be spawned in the world like the other two are. So yeah, once again, make sure these are here in the world if for some reason you didn't do that yet. Because if these are not in the world, the event begin plays don't trigger, and they don't work. So, okay, so let's get started in projectile base. So the first thing we want to do, we want to add a static mesh, and we'll call it the bullet. So we're adding it here instead of in the parent, because then when we're referencing the object pool class in literally any other thing, then we won't be referencing this exact static mesh, right? Because in footprints you're gonna have a decal, not a static mesh, and same with the bullet holes and all that kind of stuff. Okay, so we've made our bullet, and we also need to add in a projectile movement. Okay, so if you are unfamiliar with this, the projectile movement is a physics-based component. This is what's going to be driving the physics behind our bullet. Okay, it's not going to be the normal physics that you're probably used to using. So in order for this to work, the bullet needs to have no collision. Okay, no collision whatsoever on the bullet. And the box collision, we are not simulating physics. Do not simulate physics on box collision, or your projectile movement will assume you're doing other stuff and not do anything. You need to have the projectile movement actually handling the physics, so we cannot be simulating physics on the box collision, okay? The next thing we need to do is we need to come down here. Let's select projectile as the collision preset so we get all these set up. But we need to select custom now. And we need to change collision enabled to collision enabled query in physics. And one more thing. So our projectile by default is going to collide with our weapon. It's just going to happen just based on where the muzzle flash is. So we're going to create a new object response here called weapon. So let's hit compile. Let's go to project settings. Just type in channel to the search bar, and it's down here. Okay, so a trace channel is what these are. We made one for our interactable before for when we're doing a line trace. And then we also have object channels. So these line traces are going to trace all of these object channels and return back what they are. So, and if it's told to ignore a specific object channel, then it's going to skip over it and not return it at all, which is what we're looking for. So object channel, we're going to make a new object channel, call it weapon, and we're going to default response is going to be to block. Okay, we're going to hit accept. And we're going to close that. We're going to hit compile, and then you'll see that weapon has now showed up here. So we're going to ignore weapon. And we need to open our weapon class right now. Weapon class. We need to go to our box collision on our weapon, and we need to change our object type to weapon. Which long story short, I did this once before. So yours will say probably world static or dynamic or something. We need to be on weapon. Okay, so we're telling it this object is a weapon. So now it'll ignore it. Okay, so that's all done. That should be it for collision settings. But the reason I had us do a box collision is because the sphere and the capsule component are really hard to manipulate around your object. Because once you make a collision box the root, you only get scale to manipulate. You don't get location or rotation or anything like that. So the box extent, you can actually, collapse it and, do stuff with it, which is great. Okay, so the bullet, we need to scale that down. Make sure you lock it, and then 0.5, because the static meshes for the rocket and the bullet in the pack that we got are freaking huge, along with the bullet, the other things that we got, the gargantuan weapons or whatever. Okay, so that should be it. Let's just go through projectile movement. I'm just going to explain a couple of things here. Initial speed and max speed, we don't care. We don't care. It's going to say 0. That means that it's going to be basically infinite. Okay, so that's what we're looking for. Rotation follows velocity. You're going to want to enable this on the RPG specifically. Why don't we just do that now so we can just not worry about it? So we'll open the... Whoops, not those, sorry. Actually, we need to open the RPG anyway for later. And then in projectiles, rocket, and bullet projectile, we'll open those. Okay, so the rocket projectile, we are going to enable rotation follows velocity. What this means, if this is disabled for the rocket launcher, the rocket travels quite a bit slower than the actual bullet. So when it falls, it's going to do this. It's going to basically keep its rotation the same. If you have this checked on, it's going to update it when it starts to slow down. Okay, so that's how that's working. So let's just go back to the projectile base. Initial velocity, local space, that has to be enabled, or else anytime you look anywhere, it's going to basically shoot the bullet based on world space, and you don't want that. You want it always to be shooting in the X direction of local space of that bullet, okay? Okay, everything else, bounce, doesn't matter. Simulation enabled, this is what enables the projectile to actually work and have simulation, and you do want sweep collision on. That means it's checking its collision as it moves. Anytime it hits something, it's going to return something back, okay? So you'll see that if false, it effectively teleports to the destination. If it's true, the movement uses sweeping collision check, so it's going to check and see if it hits something. Okay? The next thing I want to show you, velocity, okay? So we're going to manipulate this later, but this is what's going to control the speed of our bullet, okay? Obviously with velocity, I'm sure that's pretty friggin' self-explanatory. The last thing I want to show you down here, so there is an on projectile stop. This is pretty commonly used with projectile movement. However, this does not work with an object pool pattern. The reason being is on projectile stops only designed to fire once. So when we spawn our bullet into the world and then use it once and this fires, that's it. If you use that bullet again from the object pool, it's essentially not going to work. So do not use on projectile stop if you're using an object pool pattern, okay? The one we need to use instead, if we go to our event graph, is going to be from our box collision. We're going to right click, add event, on component hit. This will fire every single time we hit something, okay? All right, so inside here, we're going to use event begin play later. I'm just going to show you guys something funny later. We're not going to use event on begin overlap, and we are going to use event tick. So let's just start with the tick thing. So we just need a debug thing to essentially show us the projectile's path. We'll drag it there. We will debug draw an arrow. Okay. Get actor transform. Or actually, we just need location. Get actor location. Okay. Let's plug that into line start and line end. We just want it to be the same spot. Arrow size, I think I had it at like 5. The line color, let's make it yellow. And duration, let's say like 7 seconds. And thickness doesn't matter. So let's do this. So, okay, so we're doing this because when we shoot the bullet, every single frame, it's going to basically draw a square in the sky. And it's going to show us the path that the bullet is taken the whole time. Really, really handy just to make sure that it's going where it's supposed to go. Because you don't, like, you can have it be a lower projectile speed and then try to make sure it works first and then figure it out later. But I mean, yeah, it just adds a bunch of extra work in my opinion. So, okay, so that's done. Let's put this on top here. Okay, so on this component hit thing, we're going to promote hit to a variable. And we'll just call it hit. Okay, let's make some other variables too. We're missing some stuff. We're going to do explosive. And that'll be a Boolean. That'll be specifically for our rocket launcher. We need a float called desired velocity. And that'll be a float. One more called, impact force. All right, so those are the ones we need. So from hit, we're going to come out of there and get a sequence or branch. Yeah, we're going to get a sequence. First thing, let's check and see if this is explosive. Okay. This is explosive. Guess what? We're not doing that yet because we're going to do that in another video. Okay, so we'll just comment box this explosive question mark. And that'll be in another video, which is going to be where we do our decals / impact effects, sound effects, all that kind of stuff. It's going to be super cool. So we'll add another reroute node, and this is going to be also a separate video where we damage our enemy. Enemy. Damage enemy, everybody. Jesus. Stupid. Anyways, and enemy. I almost did it again. Enemy. There we go. Okay, so we're going to damage our enemy. Let's get a print string as well. This is just going to tell us what we've hit, which is going to be very invaluable. Okay. And finally, we are going to set in use to false. Okay. So we've hit something. We are going to register all of the data that's regarded what we've hit. And then we're going to check if it's explosive or not. If it is, it's going to blow up. If it's not, it's going to carry on its way. We're going to damage our enemy. It's going to tell us what we've hit. And then it's going to set in use and return it to the pool. Okay. It's also going to hide it. So that's super handy. Okay. And then the second part of the sequence is we're going to get our hit. And we're going to break it just to keep it clean, because if you split it like this, it just like gives you all that and you can't like retract it, which is super annoying. So yeah, we're just going to break it. We're going to ask ourselves from this hit thing, from our hit component, is simulating physics? That'd be nice to know, hey? So is it simulating physics? Then we're going to plug the bone name into the bone name, and then we're going to add a branch here. Okay, so if this is simulating physics, we're going to add some force to it. So let's drag out of impact point, and let's add impact, or is it impact, or is it... Sorry, impulse. Add impulse at location. Okay, let's drag out of true, and the target will be the hit actor. Or pardon me, the hit components. There it is. The location will be the impact points, and the impulse, we're going to break that for a second. We're going to get it at the impact point, and we're going to multiply it. Let's plug this into impulse, and then we're going to plug in our impact force float. Okay. This is messy, and I don't like it. Something like that. There we go. Okay, so, oh yeah, and bone name, I guess we should plug in hit bone name to that as well. There we go. Perfect. Okay, so we got a bit of sketty here, but yeah, we're going to add impulse at the impact point, and we're going to multiply the impact point, which is a vector, by the way, by the amount of force we want to apply to that spot, and then we're going to plug that into the impulse. All right, so that'll add some impulse. We'll display that later. So that's the first little bit here. Let's go into our bullets now, and let's set some parameters. So we'll go to the rocket, and we'll first set the rocket static mesh to rocket. Did I rotate this 90 degrees? Because I forgot to do that before. Projectile base static mesh. I did not. Okay, so in this projectile base bullet static mesh, we're going to rotate this minus 90. Okay, and we're going to hit compile. Go back to our rocket projectile. Now let's get our box collision, and let's just kind of size this up here. The size actually does matter, because later on when we do our decals and stuff, or even you don't want a big ass bullet hitting somebody and they'll be like, how did that hit me, you know? So that's pretty good for the rocket launcher, to be honest. So let's hit compile, and let's go to class default. So let's set all these. Explosive, true. Desired velocity. Sorry, I had something itch my arm. Desired velocity, let's do 5,000. Impact force, let's do like 500. Let's do 300. We'll just see what it looks like to start. Debug text, we can just say rocket projectile. Oh, you know what we didn't do back in the grandfather thing? Text render, we need to come all the way down here. Hidden in game. We don't want to see that. That'd be super awkward. Okay, rocket projectile. We are not in use. Lifetime, I'm gonna do 7 seconds for that guy. Okay, that's hit compile. That should be it for this. Oh, no, it's not. We need to add a trail effects here. Okay, so we're gonna add a cascade particle effect system. So this is only applying to the rocket projectile. So that's nice that you can customize each individual thing. So if you wanted to add a tracer or something as well, you can do that. We'll click on particle system and we will add the fire from the starter pack. Okay, and you can see the fire is GIF enormous. So we're gonna reduce that by half as well. Okay, don't worry about the direction that it's going because this projectile will be obviously going forward and the fire will be being pushed to the rear. So as long as it's there in general. Okay, that should be it. Oh, we have to optimize that actually. So 2 things you got to do for the fire. I talked about this in my 10 mistakes video. If you guys haven't seen that, check it out. It's got lots of good stuff in there. So we're going to come down to LOD under advanced. This is our call distance. We want to optimize this so we don't see the fire after a certain distance away from the player because that just will drain your performance if you have a bunch of rockets going everywhere. So the desired max draw distance, I think like 4,000 is probably pretty good. Okay, so after it passes 4,000 units away from the camera, it's going to stop rendering it. Okay, let's hit compile again. I compile happy, I guess. Yeah, and then after the call distance, we have to go to our event graph. Let's, first of all, I don't know why it didn't do this. That's weird. These should have a parent call to parent function. So the event tick, we're going to add a call to parent function. Okay, this means that the event tick's going to do the same thing that it does in its parent. We're going to delete this because we're not even using it. And the event begin play at the same time as well. Okay. Okay, so the other thing we need is so like we can call set in use. We can call that function. We can also call the event itself. Event set in use. So anytime this event is fired, this event will fire inside our rocket projectile when it's being used. So let's right click and we have to add a call to parent function so that all of that stuff is still used. Okay, we need to grab the particle system and we need to activate and deactivate. Okay, and let's get a branch from in use. And this will be true, and this will be false. Okay, so this is just optimizing the particle system so that it's not rendering it while we're using it. Or sorry, it's not rendering it while we're not using the rocket, okay? Let's hit compile. While we're on the topic of the rocket launcher, let's open up the actual gun, rocket launcher gun. So, earlier in the series, we put this rocket on as a static mesh, just so it was there. This has no collision. This isn't doing anything. This is very, very low performance-wise to have this here. Okay? But obviously when we shoot the actual rocket, we want to hide this and Hollywood switch it with our actual rocket projectile that's got our particle effect and it's got our collision and all that, all the other stuff that we need. Okay, so we're going to go to the event graph for this. We are going to get event single fire. Okay, so when single fire is called on the rocket launcher, we're going to take the rocket projectile and we're going to set hidden in game. And that's going to be true. Okay? We only have one rocket on the rocket launcher at a time, and then we need to reload. So we're going to get the event reload math. Specifically this one because if you recall, if you're following the series, the event reload math is happening after our gun has already left screen. So we won't see this, but this is where we're going to unhide it. Okay, we'll duplicate these, and we will make it not hidden. Okay, so that'll unhide it. Okay, that's it for the rocket launcher. I'm still keeping everything open. Let's go to our bullet projectile and finish that up here. Okay, so same thing. The bullets... Sorry, the bullet mesh we got to set. Bulletto! There we go. Okay, there's the bullet. That is a huge hitbox for a bullet. If I, like, man, you were hitting headshots all the time with that. I'd be considering that guy a hacker, right? So we don't want that happening. Box collision, let's just make this a bit smaller, obviously. Yeah, if you wanted to add a bullet tracer, you could do that, but I don't care myself. Okay, so explosive, no desired velocity. So the velocity of the Barrett 50 cal, I looked it up, it was 803 meters. Sorry, it was 830 meters a second. Sorry, America, but Unreal uses the metric system, so yeah, we're gonna just convert that, which honestly is really easy. To go to millimeters to centimeters, you add a 0, and then to go to centimeters to millimeters, you add another 0. So this, in this case, would be 83,000 Unreal Engine units, which are millimeters. So that's what we need. So 83,000 millimeters a second. And that's what we need. Impact force, let's do 20. We don't need anything super powerful for the... Actually, let's do 100. Let's try 100. Let's see what it does. We'll just... This doesn't matter, but we'll just call it, you know, bullet projectile. Again, we're not going to see that in the world anyway. Lifetime, let's make this 3 seconds, and that should be it. Let's hit compile. Okay, if you think this video is almost over, it's not. So, alright, so that's all the projectiles set up. Now we need to do some stuff in our weapon class. Weapon class... Okay, so we're in the weapon class. Let's first make... we're gonna make a couple functions and a macro, okay? This is kind of complicated. It took a lot of trial and error to get this to work, so I'm gonna do my absolute best to explain this. So, first we need a projectile fire function, okay? Next, we need a calculate projectile transform, we'll call it. Okay, and then we need to make a macro called weapon projectile location / rotation calc. This should make sense when we're done this. We are gonna start with this macro, okay? Okay, the reason we're making a macro is we need to use this code 2 different times. And then we need to plug it into this calculate transform, and then we need to plug that into the projectile fire. So there's a whole kind of hierarchical system here that's in play here. So, okay, so this is probably the more complicated one. All right, to start off, let's get our get socket transform, and it can be the weapon mesh, I guess, because we're going to delete weapon mesh. First, let's add an execution pin here. We'll call it. And we'll do the same for the outputs. Out. Okay, so we're gonna plug this target into this input, and we're gonna call it scene component. Okay, that way we can set this dynamically outside of this macro, which thing we want to get the transform from. So it's either gonna be our gun mesh or our barrel attachment mesh. Okay. The in-socket name will be muzzle flash. That's what we want to find. Okay, let's split this, and let's also get camera manager. So the get player camera manager, we want to get that. We want to get our camera, obviously, and then we want to get actor eyes viewpoint, sorry. Okay, this is a super nice node where you can just get the direction the camera's looking without actually getting a reference to the player or the camera. So that's really nice. All right, let's start with location. So we need to calculate, we'll just put these in the outputs now. We need to calculate a bullet vector, which is a vector. And we need to calculate the bullet rotation, which is a rotator. Okay. So we need to calculate both of these for 2 separate instances. The first instance is going to spawn the bullet in our muzzle flash, which will be the vector. And then the rotation will be the angle that the game needs to rotate the bullet to so that it's pointing towards your crosshairs. Because if we were to simulate the game right now, you can see that if I switch to my sniper rifle, that bullet, if it spawns at my muzzle flash, is definitely not hitting my crosshairs. It's going to probably be a little bit to the right of it. So we need to basically offset the bullet so that it's rotated in the same direction, or in the direction that when it fires, it's going to hit where your crosshairs is. Okay, so that's what we're doing right now. And then the second instance of this is we're going to calculate the velocity of our bullet from this vector. Pardon me, from the same rotation. Okay, so let's start with this. Let's let's come out of rotation and let's get forward vector. And so this is going to get the forward vector of the current muzzle flash transform. And then we need to get a node called find look at rotation. Okay. Now from our camera's rotation, we want to get forward vector. So we're getting the forward vector of our camera's, like the middle point of our camera. And we're going to plug this in. So now this is going to pump out a return rotation of pretty much the difference in rotation between this forward vector and this forward vector. It's getting an angle essentially, and then it's setting this rotator to that angle. Okay. Now we need to get the forward vector of the new rotation, right? Because these two were from the original, and then we found the new one, and now we need to get the forward vector of this new one. Okay, we need to drag this, get an add node, and I'll plug this in the bottom, and then this. Let's move this down here, and then this guy's gonna plug in the top here. Okay. Alrighty. Okay, remember this is just specifically for the location of the bullet. Because remember, a vector is also a location, it's also a direction. So the vector is the direction, and this will be the starting point of that direction. So that's the what the bullet vector will be, or the location, pardon me. Okay, so the next kind of complicated-y bit to this is for the rotation, we want to confirm that it's going to go to the exact spot that you're aiming your crosshairs in 3D space. So in order to do that, we're going to come out of in, and we're going to get a line trace by channel. Okay. First, let's make sure the trace channel is camera, and we need to add another input to this called calling actor. Okay, and that is going to be an actor. So the reason we have this guy, why does actor just refuse to show itself? There we go. Actor, object reference. Okay, so the reason we need to do this is because I had an issue in my prep project where when I was aiming down sight for my rocket launcher, because we don't actually physically aim down sight for the rocket launcher, where the sniper scope we like zoom in. My line choice was hitting my rocket projectile, and I couldn't. It was freaking really hard to like reference the rocket launcher in here without like making a bunch of casts and interfaces and all that kind of stuff. Okay, so we do have this actors to ignore, so we're gonna drag out of there and we're gonna make a array, and we 100% will hit our player. So we're gonna get player character and plug that in. We have an ignore self. I've had instances where that didn't work, which didn't make any sense to me, which I'm just gonna add it here. That seemed to work. I don't know why this didn't work and this does, but hey, whatever it is. Okay, so next, we'll just move this up. Next, we need to get our calling actor, and since this is a macro, we can't call that input function, which is unfortunate, but, and we need to drag that in here too. Okay, so we're ignoring our player, we're ignoring ourself, which is our weapon class, and we're ignoring the calling actor of this. This will become more apparent what it's for when we're doing it inside our projectile base later. Okay, so now we need to get this line trace going. So as we've done before, obviously we're getting our forward vector, and then we are multiplying it. Do that up here. Let's plug this into a addition node, or else we're gonna get some errors. We're gonna do our weapon range. Okay. Let's make sure that both our RPG, class settings or class defaults. Weapon defaults range. Okay, we have it at 3000 for the RPG, and then we'll just double check the sniper rifle and make sure that actually has a range as well before we get some errors later. Weapon defaults range 8000. Sure. Okay, that's great. Back in our weapon class here, so that we're going to multiply the forward vector by whatever that range is, and then we're going to get a new number, and we're going to add it to the original location of our actor's eyes. Okay, and then for we'll do this, and then for the start, we're just going to come out of here and plug this in, And we'll plug the +1 into the end. Okay, so now we're going from our actor's camera, or our first-person camera, right down the center, and we're gonna draw a line trace from there. Okay, so here comes the fun stuff that probably... So I bet you most of the time you get out of here and get a branch. Well, not this time. We're gonna drag out of here and we're gonna get a select node, which is all the way at the bottom here, this little one here, okay? Okay, next we're gonna get our out hit and we're gonna break that hit result. And we're gonna grab the impact point and plug that into true. And we're gonna get the trace end and plug that into false. Okay, and then we'll skinny this up because that's ugly. Okay, so what's happening here? So we're gonna draw a line trace. If we've hit something, we're going to take the impact point and we're going to use that as the spot that we're going to tell the projectile, hey, this is where we want you to hit, right? If we don't hit something, meaning that we've exceeded the range of our weapon, then we're going to use the end of the trace, which is the maximum range it has, and use that as the point for the projectile for us to say, hey, we want you to hit this point. Okay? All right, so now that we have this, we're going to drag it here, and we're going to find look at rotation again, and plug this in, and then plug this into this. So that's the rotation that we want the bullet to be in, so that it hits this point, okay? All right, one more thing we're going to do here. This is a debug thing, which is very, very helpful. So if you're not going to do that, that's up to you. Why don't I just do this? Can I do this and then this? Yeah, sure, there we go. Okay, so we're going to drag out of here. We're going to draw a debug sphere. Okay, so I'll move these out of the way, I guess, because obviously that's in the way. So, okay, anyways, so you can comment box and say delete when it works. Or it worlds. Okay, so you can delete that when it works. Okay, so the center is going to be this return value. The radius, 2? Is that what I had? Yeah, I had 2. Line color, we can just make red, I guess. It's a different color to look at. Duration, we'll just do like 5 seconds. Thickness doesn't matter. So we'll hit compile. That is the end of this macro. So hopefully, if you guys need to watch it again, because I'm just going to make sure that I slowly go along here so you can see what I've done. And I always do this in 4K so that, you know, you guys can read stuff. Alrighty, so that's the macro. We're going to exit the macro. Okay, now we're going to be working in the calculate projectile transform. Okay, the first thing we need to do, we need to get our player. They're right here. Player, right here. Get player. We need to get the equipped weapon from our player, and we need to promote this to a local variable. Okay. This calculate projectile transform also needs an input of calling actor. Okay. Next, we need to get our gameplay tags. Get gameplay tags. And we need to get has tag. And the tag we're looking for specifically is our barrel attached. Do we have a barrel attached? Because that's going to change where we're spawning our bullet. Okay, let's get a branch. If we have a bullet, we're going to grab that macro now. Macro, where did you go? Project this one here. We'll just drag 2 of them out because we're going to need 2. Calling actor, we need to put something in here or we're going to get an access none error, so we need to just put self because it's the weapon class that's calling this one. True will go into here, false will go into here, and the scene component for this is going to be our barrel instance, which we made a couple videos ago. This is the specific instance of our equipped weapon so just so we have an object reference, and then we need to get our attached actors, pardon me. Get attach, there we go, get attachment mesh, that's what we want, and we're going to plug that in because this goes up here, which is a scene component. So now we can plug that into scene component, okay? All right, down here, we're just going to get our gun mesh or a weapon mesh and plug that in to scene component. Okay? Okay, we are going to get out and we're going to hit a return node. And the return node needs our vector and our rotation. Let's duplicate that and let's plug this in. Oops. Oh my god, just go in the goddamn pin. Bleh. There we go. All right, there you go. That's that function. And then finally, we need to do the projectile fire. Okay, so to start off, we are going to get actor of class. This is the other bonus of doing it with an object pool pattern. Because we can call the specific object pool that we want anywhere in the engine with a get actor of class, because we're only going to have one bullet manager in the world, and the way the get actor of class actually works is it gets the first instance of the actor in the world that it finds. So it'll be whatever the actor is _ 0. So that's the one it's going to get. And then in this case, obviously, we want the bullet manager, and we're going to get promote this to a variable and call it bullet pool. Okay, and let's get bullet pool, and let's right click and convert to validate get. And then now, anytime the bullet pool is not valid, we are going to get and set this. Okay, next let's get our function we made, the calculate projectile transform. We're going to plug that in. The calling actor is going to be self. Oh damn, I realized a mistake, sorry. In here we did self. We're going to just, I mean, it actually will matter, so we can't do self. We have to do the calling actor function input for the calling actor on these macros, okay? Calling actor, okay, there we go. That was a detriment. That would have been a detriment anyway. Sorry, back to projectile fire. So yeah, we're gonna calling actor, now we'll do self, because it's gonna be the weapon class. And we're gonna plug is valid into here as well. Okay, this we're going to make transform. Next, we are going to create a new variable called bullet projectile. And that will be a BP ProjectileBase class reference. Okay. Let's set those while we can. So we'll hit compile. We'll go to the bullet. Pardon me, it's going to be in our sniper and our actual RPG. Okay, so down here, bullet projectile, that will be the bullet projectile in the sniper. And in the RPG gun, it'll be bullet projectile, rocket projectile. Okay, let's hit compile. We'll go back to our weapon class. And now we need to find out if this bullet projectile equals a bullet projectile. Projectile. Okay. Reason we're doing this is because we have the two separate components in our bullet manager, so we need to know which one to run. Okay, so if we do have our bullet thing, we're going to get our bullet pool, and we are going to get the bullet component, which is this one. So get bullets, and then we're going to spawn from pool. Okay, that's true. Here's that transform I was talking about, not to worry about, and we're going to plug in this guy, because this is the correct transform that we want to spawn it from, okay? And then if it's not a bullet projectile, that means it's a rocket projectile. And we're going to get our bullet pool, get our rocket, get rockets, and we're going to spawn from pool. Boom, and then we're going to plug this guy in here. Let's do this, make it somewhat neatish. Okay. That is everything we need to do in this function. We are going to close this. We're going to go into our single fire logic. This might be slightly different from your game. The only two guns in this project that I'm doing that fire projectiles only fired in single fire logic. If you have any other guns in your game that fire projectiles, you need to put it in all of the subsequent logics here. The single, the burst, the auto, all of these, you need to put those in, this in there as well. But for this particular project, I'm only doing it for single fire. So we're going to get our gameplay tags, and we need to check if we has tag, and we have a projectile tag. Okay, so we'll get a branch for that, and we should double check that our sniper has projectile and our RPG projectile. Perfect. Okay, they both have projectile, so that's great. False is going to plug into our hit scan, so that all of our hit scan weapons will keep doing the same things they've been normally doing. For projectile, we are going to just grab that function, projectile fire, and plug that in. Okay, that's it. That's it for weapon class. Almost done. Then we can fire stuff, and it's going to work. Hopefully. Projectile base. We're going to go back in there. We're going to come up top here, and we're going to get the event in use, or set in use, okay? We're going to add a call to parent function so that our parent can handle all of that stuff, okay? But we do need to come out of in use and get a branch, and we need to do some stuff here. Okay, so if it's false, for some reason I have the, or we need to find the handle from our parent class. Okay, remember this guy, handle, that's what we're getting in our grandfather class. Okay, and we need to clear and invalidate timer by handle. Why are we doing this now? I mean, it's in my notes, and I worked on this for a long time, so that's why it's there. Theoretically, this should be fine anyway, because we'll be setting in use to false, and then it would go and it would clear it in this class right here, but it's, again, it's a fail-safe. I don't think doing this, again, is going to affect anything personally, so. Okay, and finally, we need to get our projectile movement, and we need to deactivate it so that our projectile movement is not participating in the game. And then we also need to set velocity to 0, 0, 0. We need to clear our velocity so that we can reset it later, okay? Okay, so the true is a little bit more interesting. We're going to get our projectile movement, and we're going to activate it. Okay, and we're going to reset. Okay. Next, we need to get our player character, and we need to get the player reference that we made a long time ago, the interface. Okay, so now we have a reference to our player. We need to get our player's equipped weapon, and we need to get the function we made that was projectile, calculate projectile transform. Okay, this is where we're going to be calculating the velocity of our bullet. Okay, the calling actor, we're going to say self. Now we're referencing our projectile base. So now when this is running, the line trace is not going to hit our bullet mesh. Okay. Okay, so after this, we need to drag out of rotation, and we need to get the forward vector. Then we need to multiply it by our desired velocity. And then we need to get our projectile movement one more time and set velocity. Okay. And plug this in. All right, this should work. There's actually two issues that are going to come up, but that's on purpose. I wanted to show you guys some stuff. Okay, so let's hit play, and our game didn't crash. That's super nice. Okay, so now we're going to get our sniper rifle out. We're going to shoot, and you can see that this bullet... Am I crouched? I seem kind of low. Oh, yeah, I was crouched. Anyways, that is our impact point. So you can see that that's working properly. That's telling the bullet where it wants to be. Okay, let's get our sniper rifle. And then when we shoot here, it's the same thing. It's exactly where our crosshairs are. So you can be moving, and it's going to shoot based on where your crosshairs are. Super awesome. Okay, and it works both with the aim down sight and with the hip fire. So, and when we shoot into the air, you'll see that nothing happens. There should be a trail there. What the hell? Okay, so let's fix what the issues are. So first of all, we didn't plug in the hit actor into our print string, so let's do that. Now it's going to show us what it's hit, which is extremely valuable specifically for projectiles, because if they're not appearing or destroying themselves or whatever the case is, they're obviously hitting something that you don't know about. So the sniper rifle, you can see that we're hitting the cube, and we can see that our physics also work. Yeah, we gotta dial that back. That's pretty strong for a sniper rifle. But anyways, so yeah, that's obviously working for that. We're hitting the cube. But for the rocket launcher specifically, we're going to shoot, and it doesn't hit anything. That's strange. Go back to this. We're going to do this, and it's still saying it's not hitting anything. So I knew this was going to happen at some point. I knew this was going to happen. So our RPG didn't fire because I forgot to add a call to parent function for both of these. So when we shot single fire, it didn't do what's in the parent function, and it just hit our mesh and then didn't do anything. So we're going to add a call to parent function and add it to our rocket launcher's single fire and our reload math. You know what's funny? I literally did this last night too. Last night. Well, this video is coming out in a week. But yeah, last night when I was testing this. But yeah, okay, there we go. Now this should all work good here. And the two issues that I've predetermined are going to happen. Okay, so we're going to shoot our rocket launcher. Sorry, we'll shoot our sniper rifle first. We're hitting the cube. We'll use this sniper scope, and this is all working as intended. Okay, so now with the rocket launcher, we're going to shoot it, and you can see that it's hitting our character's mesh. Okay, so we drew a line trace, but it destroys itself right away because it's hitting our character. So the bullet's a bit smaller, but the RPG actual mesh is a bit bigger. So what you can do to avoid that is in our projectile base, we're going to use this event begin play that I said we'd use. And we are going to drag out of here, and we're going to ignore, there we go, actor while moving, and it's going to be the box collision. Okay, and the actor we want to ignore is the get player character. Get pawn probably will work too, and should ignore should be checked true. Okay, now let's have a look. Let's hit play. Let's do this. So we should be seeing a trail. Why is the trail not working down here? Maybe the arrows are too small. Maybe 20. No, I did 10 before. I did 10, and then I think thickness I made. Let's make 10 just to. Oh, I did have it. Thickness is 10. Sorry about that. Okay, thickness is 10. Blah blah blah. Now this should work. Switch to my show. There we go. Okay, so there's the trajectory of our bullet. That's pretty cool. So now anytime you shoot, it'll draw that debug every frame. So you can kind of get an idea of what your trajectory is going to be, and it even works for this. So there, you look to the side, there it is. Very cool. Now for the rocket launcher, it'll do the same thing. And I find that the rocket launcher falls too quickly. Okay, so what we're going to do... Oh, let's test the... Yeah, that's pretty good. 300, the impact force. Oh, yeah, buddy. Look at that. That's pretty good. Anyway, so to deal with the gravity thing, you can come back to the specifically the RPG projectile, and we can get an event begin play. And on the parent event begin play, we are going to drag out of there and on projectile movement, sorry, and set gravity. Set projectile gravity scale, and we can just half that. Okay. Now the rocket launcher will fly a little bit farther. Okay, get the rocket launcher. Way better, buddy. Way better. And you can see the calling works as well. The projectile thing stops. That's pretty good. I'm pretty happy with that. Okay, sweet. So that's the end of the video, but don't go away just yet. Next video, we're going to be doing a debug session. So we're going to basically black box test our own games. A lot of tutorials don't do this, and it's really annoying. I've intentionally not fixed a lot of bugs in here on purpose because I knew I was going to make this video. So what I want you guys to do, I want you to play your game like you normally would as an actual player, okay? So like pretend these are enemies, like run around and jump and like shoot them and like try to like active reload and like do a bunch of cool stuff and just find bugs. Make like essentially bug reports for your own game. So what happened? How did you recreate the bug? All that kind of stuff. Make a list. You guys can let me know in the comments down below what this list is for the next video. I'm going to black box test my own game, and I'll explain what that is in the next video. I'm going to black box test my own game as well, and I'll come up with a list, and then I'll prep the video around that. But yeah, so this is going to be basically a debug video. Very, very important that that's actually included in your game development for your game. Okay, so like there's a thing right there how like when I'm sprinting and then I let go of shift and everything, I just snap back. Like that doesn't visually look good, so we'll fix that. I noticed earlier that when I reloaded my completely empty rocket launcher, it just like fully filled it with ammunition for some reason, so that's obviously a bug I gotta patch. But yeah, next video we'll work on that. There you guys go. Now you have an epic projectile system in your first-person shooter game. Hopefully this video was helpful. I learned a ton even prepping this video. I had so many issues that I had to overcome, and I had to learn a lot of stuff. So hopefully I passed that along to you guys. And as always, if you could like and subscribe to the video, and consider joining the Discord. We got lots of great game devs in there, lots of people that like to chat. We can debug your game. We can give you guys ideas. It's a great place to be. And just a reminder, make sure in the next video you do your black box testing for your games. You guys can comment down below any issues that you did find that you want me to maybe put in the next video. I'm going to do a black box test of this game on my own, and then I'm going to come up with my own lists, and then most of the time it'll probably be the same as your guys's, but everybody's game is different. So if you want something specific that you want me to cover in that video, definitely put it in the comments below. Special thanks to my Ko-fi members. If you guys do want to support what I do and get awesome perks at the same time, head over to my Ko-fi page and become a member today. Otherwise, keep learning until you game over. Peace.